Much like a child experiencing the wonder of life for the first time, there is still so much to discover when it comes to artificial intelligence. The technology is still in its infancy, and those in the industry are trying to work out constraints that allow AI to constantly learn and gather information, but give it boundaries or rules to keep it honest. Casimir Wierzynski is the Senior Director of AI Products for Intel, and on this episode of IT Visionaries, he discusses some of the ways companies are working together to grow the technology. Plus, he explains how encrypted data is leading them down new paths and the importance of an open source ecosystem. Enjoy this episode. IT Visionaries is created by the team at mission.org and brought to you by the Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Build connected experience, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform. This podcast is created by the team at mission.org.
Welcome to another episode of IT Visionaries. I'm Ian Faison, host of IT Visionaries, and we are joined by a special guest. Kaz, what's going on?
Hey, what's going on, Ian?
You know, it's a great day, and we are excited to talk about some of the really cool stuff that you're doing in Intel, a little bit about your background and career. But first, how did you get started in technology?
That's a great question. I think I got started on my parents' Apple II way back when, writing games like Pong and Breakout and things like that. I eventually, kind of got into electrical engineering and computer science. Took a bit of a detour into financial markets, actually, and I was a derivatives trader for about 7 years on Wall Street. And then I was always interested in AI. So I said, you know what, enough of trading on Wall Street. I think I want to go work in the basement of a building and clean up after rats and do neuroscience experiments. So I did that for 5 or 6 years. I got my PhD in neuroscience. Still always interested in AI, and it was around the time when people wanted to start building chips that were modeled after the brain. So I got into various R&D projects around what's called neuromorphic computing, and then finally came into Intel around the time when they were building out their AI products group and really starting to build dedicated hardware for AI, which was really exciting.
Yeah, so tell me a little bit about that. What's the scope of your role at Intel?
So at Intel, I look at kind of next-gen ideas around AI, and it can be starting almost at the foundational levels of, what are some new ways of building transistors that might be useful for AI chips, all the way up to, what are the latest algorithms that people are going to be using, maybe possibly besides deep learning or new ways of doing deep learning, all the way out to, what are the ways in which people are going to deploy AI systems. And how does Intel need to prepare for that? And it's in that last mold of questioning and research that we really started to look at this question of privacy around AI. And over the last couple of years, we've just been watching this looming, almost kind of collision course between the needs and the promise of AI, which, in its modern flavors is based on machine learning and learning from data. And the fact that, these data are private and sensitive, and people maybe don't necessarily want them, flying around, uninhibited in any way. So that's kind of what brought us to this line of work.
Yeah, so expand on that a little bit. Like when you're talking about these type of projects, it seems like every, CIO, CTO, technology leader that we talk to, we talk about AI, we talk about the impacts that AI will have on the business. We rarely talk hardware and what that means. So like, what does hardware look like in AI?
Well, one of the most exciting techniques to come along in AI, and especially the machine learning flavor of AI, is deep learning. And deep learning is essentially using models known as neural networks to learn a function, some kind of relationship between a certain one set of data and another, essentially. And in order to learn this function, in order to figure out what the parameters of this model are from the data, you have to do a lot of number crunching. So you have to blast through, in some cases, billions of data points, to extract a model that might have millions of parameters. One of the ways in which the field has come to this exciting point is the fact that we have these very large data sets available to us and all this additional computing power. So there is kind of a direct link between the ability of AI systems to do a good job and how much data and compute you have available to build those systems. So that's why you kind of end up looking at, having big companies like Intel look at hardware specifically for this flavor of AI, because its success is so tied to computational power.
And then as you're working with organizations to kind of harness that, obviously Intel is famously inside computers everywhere. How does that work? How would those types of like machine learning capabilities and hardware, fit into a broader spectrum of, things that companies are using? Is it going into like, what are the types of companies that are leveraging that technology?
Well, it varies quite broadly. I think, so I don't want to give the impression that suddenly every single company that wants to make use of AI has to, themselves buy some huge pile of hardware. Otherwise, they're not going to be able to make any progress. So there is a kind of a very exciting AI ecosystem that's growing up around this phenomenon, where you have companies that will go out and take very large data sets, build a model, and then they make that model available to other companies as a service, for example. So like, let's say, I don't know, you're a company that sells flowers, and you might want to have some AI application that, I don't know, somebody sends you a picture of their kitchen, and then you want to suggest what the best flowers would be in that kitchen. You, as a flower company, you're not going to go buy some supercomputer to build this model, but there's an AI ecosystem out there where you have data scientists, hardware makers, cloud service providers who will do the hard work for you and build the kinds of models that you want. And then you can, as the flower business, can focus on your core competencies and say, okay, I've got this really cool website for my flower shop. I will be able to build much more easily some kind of application that can do these really smart things. Under the hood, it's making use of API calls to these underlying services that other people have built.
And so are those the cloud service providers that are, purchasing those things? Are those people building like on-prem? Like who are the types of people that are building those capacities?
There is this kind of ecosystem where there's a range of deployments and deployment styles. So, clearly cloud service providers are building very interesting capabilities for their customers to be able to do machine learning on their particular data. But, some of these capabilities are also being made available in on-premise situations for customers who prefer that. And there's even on top of that, a whole set of edge analytic ecosystem partners. So for example, if you wanted to, you have a clothing store and somebody walks in and there's a webcam that takes a picture of the person and then suggests some clothes to wear, those analytics could be performed right there in the store, and they would probably be running on a different category of hardware, maybe inside the camera itself, for example. So it gets deployed at many different scales in different ways, depending on the use case.
It's funny. We did a little mini series on Edge and talking to some, of the leaders in Edge, Vapor.io and others, and just like the massive amounts of compute that will be added over the next decade as, things like machine learning become more and more prevalent. I'm curious, like, what do you feel about kind of like where we're at as an industry or an ecosystem in terms of like the need for those sort of things? Obviously, Intel is at the forefront of this, of the hardware piece of this, but it seems like hardware is going to be extremely critical and people won't necessarily know like they did in the past, like older, IT organizations who had to deal a lot more with hardware. Well, a lot of those companies that are born in the cloud don't really have to worry about that anymore. However, the players in Edge or the players in that space are going to have, almost an entirely new problem set as, you expand the Edge like across, the United States or the globe.
Yeah, I guess my comment on that is that yes, as you mentioned, Intel, we clearly play an important role in the hardware ecosystem. I think from the point of view of AI, and actually this also relates to the privacy topics that I've been working on most recently, we feel like it's important to really take a systems level approach to these kinds of problems so that, yeah, clearly these workloads are running on underlying hardware and they need to run as well as possible. We don't want customers having to think about specifically quote unquote hardware problems, right? They have a business problem and we want to address the entire business problem. One of the strengths of Intel is that we can help them attack that, across all the layers. So across, whatever the cloud component might be, the storage piece of it, the interconnect, the software glue in between them, all the way out to whatever edge analytics have to be done. We've taken that same approach with privacy. For example, we know that there are data scientists who are wanting to build models that operate on sensitive data. So for example, let's say you're building a model to find the contours of a brain tumor in a CT scan. You know that probably, most likely you're going to be dealing with sensitive patient data. Wouldn't it be cool if you could just do your ordinary data science as you normally do it with your regular tools of your choice? But then once you have a model that performs well, you would like to be able to flick a switch and have it so that this model now is able to operate not on raw patient data, but actually on purely encrypted data, and have those data stay encrypted the whole time while you're operating on them. So these are the kinds of the capabilities that we're thinking about at Intel, kind of looking at the overall business problem versus like, okay, I need to buy this exact chip here. Does that make sense?
Yeah, it does. No, it definitely makes sense. And I was going to add, that was kind of going to be my follow-up, is like, how does this blend to the business use case? Because, it seems so interesting to me right now that the landscape, you have specifically like IT, for example, moving closer and closer to the kind of customer experience side of things, like to really understand what, aligning the business around that customer experience, something, we talk about a ton on this show. And I was curious, how do you look at that from a hardware perspective as a piece in kind of the overall tech stack?
Yeah, again, looking at it from the kind of the AI plus privacy lens, I tend to look at it more from the top down or as you put it, the customer experience. So you kind of trace down, okay, how do I want this system to work? And what are the constraints on who's allowed to see what data? And working from those, you could say, okay, well, ultimately, when I push it all the way down, I know that to run well, this aspect of privacy is going to require some kind of, some particular kind of cryptography system that, in order to run at its peak performance, requires this specific kind of hardware. But that might be in some ways the last thing that I think about. I really want to think about the almost like from the point of view of the developer, right? How is the developer going to build this thing? And in some ways try to shield complexities like cryptography and data science and kind of as much as possible.
Yeah, I want to expand on the privacy piece. So tell me a little bit about the work that you're doing in privacy. Yeah,
so we are looking at a suite of really exciting techniques coming out of the academic world just in the last 5 years. They fall under this header of privacy preserving machine learning. So it's you can think of it as like a subfield of machine learning where building privacy into the computation is actually a stated goal, right? It's not just kind of an afterthought, it's baked in. So for example, data scientists for a long time have been using data to fit models and train models. Now, if you add a constraint that says that, what if you want to learn a particular model by sharing data across 3 or 4 different data sources, but you're not allowed to actually get the data from those data sources? How would you do that? How can you somehow learn from distributed data without actually getting the data yourself? So that technique is called federated learning. Another interesting technique in this suite of privacy preserving techniques is called homomorphic encryption, where you can actually do math on encrypted data without ever getting the key, without actually seeing the underlying data. To make a very cutting edge crypto technique like that more accessible and more available to data scientists, what we did is we built an open source library called HE Transformer. It stands for Homomorphic Encryption Transformer. And it means that someone can use TensorFlow, which is like a very common data science tool, to build a neural network. And then once they have a model trained the way that they like it, they can literally change an environment variable, and their model automatically gets recompiled under the hood so that instead of working on regular data, now it works on encrypted data. And the answer that it puts out is encrypted. Only the person who submitted the inference data to be operated on can unlock the answer. So it enables all of these completely new use cases for sensitive data.
So that is fascinating. And you recently gave a talk at RSA kind of talking about like how AI and privacy don't have to be a zero-sum game. I'm curious, that is one of those things that I think everyone is kind of like waiting on or curious about is like, are these things mutually exclusive? I'm like, what are your thoughts on that?
Yeah, I think it's underappreciated, the fact that, so right now, if you want to do machine learning on sensitive data, you have to have, in most cases, some kind of legal agreement with whoever's data it is. Your lawyer gets together with their lawyer. You say, okay, here's the terms and conditions under which you can operate on the data. When I ask you to, I want you to delete the data, all these kinds of things and then you sign and then you do your work. A lot of people think that the alternative is basically, well, I don't get to work on the data at all. But there's actually a whole space in between those two extremes where you could get encrypted access to somebody's data and get useful inferences out of it. Or you could pool two people's data together into a larger data set without actually taking ownership of either of their data and build some model out of it. So there's these really interesting intermediate combinations that we'd like to make easier for developers and business leaders to make use of.
Yeah, that's really, really interesting. How much does that play into what blockchain can do in kind of a similar but different vein? Because I know that that's like a sort of a use case for blockchain as well.
So I think I have to confess, I'm not a blockchain expert in any way.
Neither am I, so that's perfect.
Yeah, I think it comes from that same spirit of looking, pushing the operating models into different parts of the design space to think like, okay, things that used to be centralized, could they be decentralized, for example? And I think of federated learning as being in that same spirit, where normally you think, okay, well, if I want to work on 5 people's data, first I need to put them all into one big data lake, and then I'm going to work on all those data together. And whereas, like blockchain, federated learning is kind of saying like, hey, well, there may be a more decentralized solution here. Maybe you can have each of the data owners, each of these 5 owners, start with some initial version of a machine learning model. They can train that model just based on their local data, keeping everything, local to their environment. Those updates to the model that they propose based on their local data could be shared with some, trusted central entity. But then that new model that everybody comes up with gets pushed back out to the other members of the federation, and then you operate on it again. And then this process keeps making this model better and better and better. And this model will be informed by everyone's data, but it was never built from a central data lake in the first place.
That's absolutely fascinating. Wow. So I want to kind of switch gears a little bit towards some of the stuff that you did at Qualcomm, specifically some of the projects that you worked on, some of the work being used by NASA on the 2020 Mars rover. Can you share a little bit about those projects for the listeners?
Sure, I could. So the Mars rover work that you refer to, this came out of some work that Qualcomm did on autonomous robotics. So there, the idea was, could you use essentially a smartphone chip as a way to drive, vision-based robotics projects? And we built a small platform for autonomy that this happened after I left Qualcomm, but eventually, I guess it made its way to JPL and NASA, and they want to include it in the rover, which was probably one of the coolest emails I've received in a while.
That is, that's a good day.
I think the I carry some of the learnings of that forward in the sense that I think there's still a lot of really interesting work in AI to be done, not just around, classifying images and kind of giving, I mean, that's definitely an important problem, but in some ways, the next generation of AI systems are really going to be more about sequences of decisions that you make versus just kind of one-time classification of data, right? So and so for example, autonomous driving is an example of that. It's not just being able to say, this is a stop sign, this isn't. It's about, okay, what's the series of decisions that a car needs to make in order to complete its mission? So this kind of goal-directed behavior, for me, that's really a nice working definition of AI. One of the things that really attracts me, one of the things that gets me really excited working at Intel is that we have, so many interesting problems and so many hardware platforms to choose from. And, with things like Mobileye, for example, we are explicitly looking at sequences of decisions over time and, kind of learning-based approaches to some of these problems. It's really such an interesting space that I think people say, where are we in the evolution of AI? And we're really just getting started,
Yeah. What are some of those other projects that you're excited about or that you can share some information about?
Yeah, one of the fun projects that I got to work on, and I'm still working on at Intel, is around brain connectomics. So this is kind of getting back to my earlier life as a neuroscientist. And I think it will inform how real world AI systems are built. So one of the mysteries of neural networks, the ones, the artificial neural networks that machine learning engineers build is, how do you come up with the right architecture? Do I need 7 layers in this neural network or 5? And should they be fully connected, or should you have some connections that skip a layer? And whenever you make these architectural choices, they for some reason they lead to either much better outcomes or much worse outcomes. That whole relationship between architecture and function is still a dark art in many ways. It's the same kind of mystery when you come to the human brain. So, there is this working hypothesis in neuroscience that all of the knowledge and the workings of the brain are really mainly a function of how the various brain cells are connected, right? There's a very strong relationship between form and function, between connectivity patterns and what the circuit does. And so people for a long time have wanted to know, okay, I mean, it's almost a naive question. Let's say you're an electrical engineer, you're looking at a brain, you want to figure out how it works. Your first question would be like, okay, well, show me the wiring diagram of the brain, right?
Yeah.
And there is no wiring diagram of the brain, because that in itself is a really hard problem. Connectomics is a project where there's a Professor Jeff Lichtman at Harvard and Nir Shavit at MIT collaborated with us. They pioneered this really cool system of slicing brain tissue very, very thin, let's say 20 nanometer wide slices, almost with like some kind of salami slicer for brain tissue. Each one of these slices gets imaged by an electron microscope. And imagine for each one of these slices, you extract the contours of what are the brain cells in that image. If you have a whole stack of these contours, you could start to rebuild an exact 3D model of all the brain cells in the brain. And you could see where they're connected, where they're not. And from that, you could extract a wiring diagram of the brain. So it's this massive, neuroscience grand challenge, because, these data sets are like, hundreds of petabytes of data. How do you do machine learning to speed up this process, to automatically do the computer vision that extracts these contours, that builds these 3D models, that gives you the wiring diagram of the brain? That's been a really amazing project to work on.
That's absolutely fascinating. Do you find that when you're, how many people in your field have the background in like neuroscience that you do? I'd imagine that that's clearly helpful because you just explained how it's helpful. But it seems like that blend of technology plus something, as confusing and complicated that we don't understand, like our own brain seems like it's the direct comparison into the unknown.
It's actually been, I wish I could say that I planned it this way career wise, but it's actually been a really great background for the reason you say, and also for the reason that, you're trying to get at the nature of what is intelligence, so what does, is it classifying things one way or the other, or is it some sequence of decisions over time, or is it being able to formulate goals? And all of these things translate into both, the biological questions and the AI questions, but also even very pedestrian things. I mean, not so pedestrian, but a little bit less airy fairy. So things like, how do you manage 100 petabyte data sets?
Yeah.
So they're like these big data problems come up immediately when you're doing things like neuroscience and collecting massive data sets. So, already back in, 2004 as a graduate student, I was like, well, how do I put together a cluster that's going to, do some kind of MapReduce type thing over these data? And those experiences still carry forward to now of like, how do you do, let's say you're a CIO and you're trying to set up your data systems so that they're friendly to data scientists, these are still really important problems.
Yeah. I'm curious, like how many, heads of technology, whether it be CIO, CTO, or, CDOs or what have you, do you work with on, a consistent basis that are trying to figure out how to add an infrastructure that can make sense of a lot of this stuff? I mean, kind of the overwhelming response that, I think we all kind of fear each other has is like the shrug emoji of like, yep, this is really confusing. And, there's no one way to look at it, but we're trying our best, sort of a thing. I'm curious to your experience.
Yeah, I find that the CIOs who are most, or kind of like the least stressed about it and maybe the most productive about it, are really listening closely to their frontline data scientists. So not taking this kind of top down, okay, this must be this because this is the way it was always done, but really kind of maybe going down a few levels in the org chart and sitting very closely with the folks who are really dealing with the data science problems day to day. Because, for two reasons. One is, being close to the problems gives you that texture that you need. But also there's just been, from a cultural point of view, data science has just been such a really open field intellectually, right? There's a lot of open source, a lot of code sharing, a lot of, best practices that are distributed across organizations. And it tends to attract people who have that same mentality, who have this kind of open mindset. So, there's a lot of really great knowledge built in at the data science layer across many organizations. And I think it's important to really tap into that.
Yeah. How is open source, a critical asset in this, new world? Because it seems like, we had Richard Socher from Salesforce on here to talk about some of the really cool stuff that he's doing and that Salesforce is doing. Obviously, they're the awesome sponsor of this podcast as well. But one of the things that was really interesting was just hearing some of the open source projects that he was passionate about that are really, really just kind of mind-bending stuff.
I think it's critically important. In fact, I mean, you can see just from our own work, this idea of making homomorphic encryption more available to the community. For us, open source was the perfect way to do that, because I think we all realize that we're now in this mode much more about, growing the AI world, right? So we want to make all of these technologies much more available, understandable, usable. Let's just, let's not get into kind of, turf battles over every inch of a very small pie. I mean, I think we're all looking at a pie that's growing substantially. So, open source is a really great way to do that. I think also it's a nice way for organizations to be very mindful about what are the aspects of what they do that are really their core comparative advantages, and the things that they want to keep to themselves. Frankly, I mean, there's open source doesn't mean that everything is open, right? You can have it forces you to really think clearly about what do I want to keep proprietary because this is the essence of what we do as an organization. And then everything else, let's just put it in a form that's where we can collaborate and capture as much value as possible.
What are some of the things over the past year or so that have surprised you, whether it's like advancements in technology or, non-advancements in technology, some of the things that kind of raised your eyebrows?
Yeah, that's a good question. I think on the privacy side, and one of the things that has accelerated our own interest in that space, some of the techniques that we looked at, like homomorphic encryption, have gone through performance improvements of, literally 2 orders of magnitude in the course of 3 years. So there's just been, it kind of illustrates that once a problem becomes, quote unquote, interesting enough and you get a bunch of smart eyes on it, you can make really rapid progress. But that's even faster than I expected. In terms of non-action, I still think that there are still, on a theoretical level, I'm just surprised that there hasn't been more of an understanding at this point of some of the core mysteries around why deep learning works so well, frankly. I mean, there have been some interesting developments just in the last few months, but still there's this kind of, for people who are used to doing data science, they might say, well, it feels a bit unintuitive that I might have a model that has more parameters than I have data, and it still works really well. That seems weird, right? Like you wouldn't normally think that, because if you have a model that's too flexible, then you're going to worry that when you try to learn data, you're just going to overfit on the data that you have, and you're not going to be able to generalize to new data. But somehow with deep learning, it is able to generalize to new data, even when the number of parameters is very, very, very high. So there's something on kind of a data science level that's still kind of mysterious about how deep learning works. We'll get to it. It's taken a little bit longer than I expected, frankly.
Are there any things that you've seen from a business application standpoint that particularly excited you, or just kind of like the business use cases of machine learning?
Well, I'm really interested in the whole process of automating scientific discovery itself. So I think maybe this comes out of having been in a biology lab and wearing gloves and pipetting solutions from one bin into another, and a lot of scientific work takes incredible amounts of human dedication, and it's kind of like this monastic activity that's quite labor intensive. So, anything that helps automate the process of scientific discovery itself is, in my mind, incredibly powerful. So let's say in drug discovery, the whole thought that you could, instead of, well, first of all, you can clearly, put in robots that move the solution from one place to another. And I think people understand mechanical automation. But then when you start to close the loop and then you say, okay, I have a robot arm that's performing a certain chemistry experiment, and then I have an instrument that's measuring the output of that experiment. Now, if I insert some kind of AI system that can then figure out, okay, well, what's the next experiment that we should run based on what we just learned? Then you've got something quite powerful, right? Then you've got like automated science, right? So that's and some of some people refer to it as like a SelfDriving Laboratory. I feel like this is going to be a very powerful application of AI in the next decade.
Yeah, the SelfDriving Laboratory, I like that. We had Alan Amici from T Connectivity on here a while back, and like the amount of sensors that go into a car and this is like why Edge is so fascinating as well. It's just like the amount of just data points that are going to be created that were never even thought of before. It's just so, it's like mind-meltingly insane just from like a single car. It feels like it's too tough for most people to even like wrap their heads around the amount of scope that just something like autonomous, like how big of a shift that thing is. And the fact that it's already happening is just wild.
Do you mind if I use that phrase, mind-meltingly awesome? It's going to be...
I mean, I guess if it is awesome to have your mind melted.
Yeah, I think, I think it's something like terabytes of data coming out of autonomous cars, or something like that.
Yeah, and you just think about like each individual car, reporting data. Yeah, it's just crazy. Okay, well, let's get into our lightning round here. These questions are fast and easy, just like the good company Salesforce. You can check out salesforce.com/platform to learn about the Salesforce Customer 360 platform. Check them out. We love them. You will too. Digital transformation at its finest. Lightning round questions. Kaz, are you ready?
I'm ready. I think I'm ready.
Number 1, what app on your phone is the most fun?
The weather. I live in San Diego.
Why do you need the weather app?
Well, sometimes there's a cloud, you got to be ready.
What is your hidden talent or passion? We've talked about a lot of them, so there's got to be a hidden one.
Well, my hidden talent is doing imitations of Henry Kissinger, but my hidden talent might be brewing coffee.
What is your favorite thing to cook or eat?
I like to roast almonds in different exotic flavors.
Is there a bot or, some type of interaction that you've had with a robot that's particularly memorable?
It's funny. The only robot I've interacted with was was one that I built myself for the CES show when I was working for Qualcomm. And it was just so much fun to watch it fly around on its own. That was just memorable by itself. We did it 100 times in the booth there.
What is your favorite animal?
I worked with rats as a neuroscientist, and I really admire them. They're so smart.
And they can swim for like 5 days or something crazy.
They're amazing swimmers. People think of them as big mice. They're not at all that. Mice are closer to insects. Rats are just, they're like small people with a really great sense of balance who can see in the dark.
What is your best advice for a first-time former neuroscientist / technology builder AI product manager? Normally we ask this for CIOs, but you're incomparable, so I got nothing.
Find an academic conference and a topic that you think you're interested in but know nothing about, and just go and talk to as many people as you can. Just dive in.
Awesome. Kaz, that's all we got. Thanks for hanging out. We'll have to have you back soon.
Okay. Thank you. That was fun.
IT Visionaries is created by the team at mission.org and brought to you by the Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Build connected experience, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform.